Let's read it. On increasing temperature, which of the following decreases? Vapor pressure of liquid. Student, on increasing temperature, vapor pressure of liquid increases. Viscosity of liquid. On increasing temperature, intermolecular forces of attraction decreases. As a result, viscosity of liquid also decreases. Next, kinetic energy of gas. This will remain constant. Rate of evaporation of liquid. Student, rate of evaporation of liquid also increases. That means the correct answer is option number 2. Rate of evaporation of liquid will remain same. Moving to next question. Let's read it. If volume of fixed mass of gas at constant temperature is increased by 25%, the pressure of the gas will be. Student, let's solve this question. Here we know that at constant temperature Boyle's law is applied. That means P1 V1 is equals to P2 V2. So P1 V1 is equals to P2. Now V2, we can see that the volume has been increased by 25%. So it will be V1 plus 25% of V1, that is 0.25 V1. Let's multiply pressure here. P1 V1 is equals to P2 V1 1.25. Now P2 is equals to 1 upon 1.25 P1, or we can say that 0.8 P1. So here we'll be calculating percentage decrease in pressure. Student, there's a decrease in pressure because the volume has been increased, so pressure must decrease. That will be equals to P1 minus P2 upon initial pressure multiplied by 100. Initial pressure is P1 minus 0.8 P1 upon P1 into 100. That will be 0.2 into 100. That is equals to 20%. That means the pressure of the gas will be decreased by 20%. That means the correct answer is option number 2. Student, this is a very important as well as a very interesting question. Moving to next, which is 83. Let's read it. If heat of combustion of methane is minus 890 kilojoule per mole, then the amount of heat released when 13.2 gram of CO2 is produced on combustion of methane. Student, I'm writing the reaction of combustion of methane, which is CH4 gaseous plus 2 O2 gases, since 2 moles of O2 are required, CO2 gaseous plus 2 H2O liquid. So it is very clear that 1 mole of methane on combustion gives 1 mole of CO2. So let's calculate the moles of CO2 produced. Here 13.2. So let's calculate moles of CO2. 13.2 upon molar mass, which is 44. That means 0.3 mole of CO2 are produced. Also, it is very clear that heat of combustion of methane is minus 890 kilojoule per mole. So we can calculate heat released during the formation of 0.3 mole of CO2. So 0.3 into 890, since this is for 1 mole, which is equals to 267 kilojoule. That means the correct answer is option number 1. Moving to next, which is 84. Let's read it. For the given reaction, A liquid to 2B gaseous, delta U is minus 4.5 kilocalorie. Delta S is equals to 12 calorie per Kelvin at 27 degrees Celsius. The value for delta G for the reaction is. Student, for this question, first of all, we have to calculate delta H and then we'll be able to calculate delta G. So I'm writing the reaction to calculate delta H. Delta H is equals to delta U plus delta NGRT. Delta U is minus 4.5 kilocalorie and delta Ng will be 2, since there is no gaseous reactant. So 2 into R, the value of R in kilocalorie will be 2 into 10 to the power minus 3 multiplied by temperature. So temperature given here is 27 degrees Celsius. So let's convert into Kelvin. That will be 300. Student, I have calculated the entire value. This will be equals to minus 3.3 kilocalorie. Students, let's calculate delta G for the reaction. Delta G is equals to delta H minus T delta S. So delta H is equals to minus 3.3 kilocalorie. So Temperature will be 300. Delta S given is 12 in calorie. So we have to convert this into kilocalorie. So multiplied by 12 into 10 raised to the power minus 3, which is ultimately equals to minus 6.9 kilocalorie. That means the correct answer is option number 3. Moving to next question, which is 85. Let's read it. Cp by Cv for CO2 gas is. Students, since CO2 is a triatomic gas, and we all know that Cp by Cv for a triatomic gas is equals to 1.33. That means the correct answer is option number 3. Moving to next question.